so this is our Honors Chemistry, section 12.3 lesson video, part 1. So today we're going to focus on limiting reagents, and then as you continue watching the other parts, it'll get to percent yield. So in a chemical reaction, an insufficient quantity of any of the reactants will limit the amount of product that forms. So let's pretend like you're super hungry and you want to make a sandwich to eat while you're studying for your stoichiometry test. But say you're like so hungry, you want to make like as many sandwiches as you possibly can. So first you're walking down to your kitchen and you're thinking like, gosh, what am I going to make my sandwich out of? Well, most likely you're going to make it out of 2 pieces of bread. Let's say you're going to make a turkey sandwich. Let's say you're going to use 3 slices of turkey. And then let's say you just really, really like cheese. And so you want 5 slices of cheese on your sandwich. Okay, so again, you don't just want to make one of these sandwiches, you want to make as many as possible. So we're going to get 2 pieces of bread, 3 slices of turkey, 5 slices of cheese, and we're going to make as many sandwiches as we can. So you get to your kitchen, and you go into the pantry, and you realize, okay, I got 20 slices of bread that I can make sandwiches out of. All right, so you get the bread out and put that on the counter. Then you go to the refrigerator, and you pull out a pack of turkey. And say you realize you got 18 slices of turkey in that pack. So you put your turkey out on the counter. And then you grab your cheese. And let's say you got 10 slices of cheese in your pack of cheese. So you put that on the counter. And so then you start assembling the sandwiches. Well, if it just depended on bread, since you need 2 pieces of bread per sandwich, you could make 10 sandwiches if it only depended on the bread. It's a lot of sandwiches. But we're also going to use turkey. Well, since we need 3 slices of turkey per sandwich and we only have 18, I'm going to run out of turkey after I make 6 sandwiches. So I'm going to have some leftover bread, but I'm not going to have any turkey to put on there. But we still want to add cheese, a lot of cheese. So if it was just up to cheese and I need 5 slices on each sandwich and I only have 10, I'm going to run out of cheese after I make 2 sandwiches. So how many complete sandwiches am I going to make? I'm only going to be able to make 2 sandwiches because once I make 2, I'm out of cheese and I'm going to have some turkey and some bread left over. Now, of course, in the world of sandwiches, obviously I could just say, okay, well, maybe I shouldn't put that much cheese on there so I can make more sandwiches. But when we're talking about a chemical reaction, it has to happen according to the equation. It can't just be changed. So once you run out of something in a chemical reaction, like we ran out of cheese here, the reaction stops. So that is what limiting reagents is all about. What is going to limit how much product I can form? So in this case, cheese limited how many sandwiches I was going to be able to make. So let's talk about 2 vocabulary terms real quick. So a limiting reagent is fully consumed in the reaction and determines the amount of product produced. So in our example, our limiting reagent was the cheese because I used up all the cheese and it forced me to only be able to make 2 sandwiches. On the other hand, the excess reagent is not fully consumed, so there is some left over. So in our example, our excess reagents would be the bread and the turkey because I only made 2 sandwiches. So I'm going to have extra turkey and extra bread. Those will be in excess. All right, so now let's look at what it looks like in an actual reaction, because unfortunately it's not quite as simple as our sandwich example because we're going to use our stoichiometry that we learned. Okay, so if you haven't gotten a full grasp on section 12.2, the basic 3-step problem, you need to go back and get better at that before you try to move on because it's the same stuff but we're just adding to it. Alright, so let's look at our first one together. So it says, what is the maximum number of grams of Cu2S, so I'm looking for grams of Cu2S, that can be formed when 80 grams of copper reacts with 25 grams of sulfur? So this looks different than the questions in chapter 12, section 2, because I have 2 starting amounts. So what I have to do is I have to go from copper to figure out how much product it can produce, and then go from sulfur to figure out how much product it can produce. Like I did with our sandwich. I figured out how many sandwiches I can make with bread, how many I can make with turkey, how many I can make with cheese, and then which do we pick? We pick the lowest amount, because once the lowest amount is made, then one of the reactants is gone. Okay, so limiting, you pick the lowest amount. All right, so I'm going to forget about sulfur for now, and so I'm just going to go from copper to our copper 1 sulfide. All right, so I start with what I know. I have 80 grams of copper. So step 1 is convert to moles. Well, since I have grams, I'm going to use the molar mass. So for copper, it's just an element, and so it's about 64 grams per mole. So because I have grams on top, I'm going to put my 64 grams on bottom, 1 mole on top. So grams cancel. Now I go to step 2, which is mole ratio. So this is where I'm going to use those coefficients. So I can see that 2 moles of copper is going to make 1 mole of our product. So I'm going to put the 2 moles of copper on bottom because I'm following my golden rule, and that makes 1 mole of my product. So now copper's gone. So as always in step 2, we officially switch over to the other substance. So now I'm going to convert to unit asked for. Well, it asks me for how many grams of our product. So if I'm going to grams, I'm going to use molar mass, but this time I'm going to use molar mass of Cu2S. So Cu is about 64 times 2, S is about 32. So when I do that, let me get to the right page. I get about, let's see. Oh, great, I don't have any of the work on my PowerPoint for this. All right, let me get out the trusty calculator and do it real quick. So I have 64 times 2 plus 32. So I get about 160 grams per mole. So because I have the mole on top, I'm going to put the 1 mole on bottom, and then the 160 grams on top. All right, so sorry, since I don't have this one pre-worked out, you're going to have to sit here and watch me use the calculator. All right, so now I've gotten to grams of my product, which is what I want, so I need to multiply the top. So I'm going to do 80 times 160 and divide by the bottom. So I'm going to divide by 64 and 2. And so I end up getting about 100 grams of my product. Now I don't know if that's how much I'm actually going to be able to make yet, because I haven't seen what's going to happen with sulfur yet. All right, so I'm not going to box in my answer because I'm not sure. So next, I'm going to go from sulfur to my product. So again, we're just doing another stoichiometry problem. So I'll start with my 25 grams of sulfur. And so step 1, of course, is to convert to moles. Well, since I have grams, I'm going to use molar mass. Well, for sulfur, it's 32 grams per mole. So I'm going to follow golden rules, and I'm going to put the 32 grams on bottom and the 1 mole on top. So next, my second step is mole ratio. And so I look at my coefficients, and 1 mole of sulfur makes 1 mole of my product. But because sulfur is on top, I'm going to put the 1 mole of sulfur on bottom, and that makes 1 mole of my product. So see, really, y'all, a limiting reagents problem is kind of just like 2 in 1. So it's like double the pleasure, double the fun, right? All right, so, well, I mean, it's fun for me because I love stoichiometry. So last step, of course, is to convert to unit asked for. Well, it asked me for grams, and so I need to use molar mass again. But y'all, if you look, we just went to grams of Cu2S. So if you're going to grams of the same substance, then that step is going to be the same. So I put my 1 mole of Cu2S on bottom and my 160 grams on top. So that's like the one shortcut I can give you. All right, so then I take my numbers, I multiply across the top, so 25 times 160, and I divide by the 32 on bottom. So I get 125 grams of Cu2S. So in reality, once the copper runs out and we've made 100 grams, I can't make any more because we're out of copper. We would only be able to make the 125 if we had enough copper to react with the sulfur. So the actual amount that I'm going to make is the 100 grams, because you'll pick the lower. And then sometimes a question will say, identify the limiting and excess reagent. So this is how you do that. Whichever substance made the lowest amount, so see how the lowest amount was 100 grams, and copper made the lowest amount, that's the limiting reagent. And then whoever makes the higher amount, which in this case was sulfur, that's our excess reagent. So that means I'm going to run out of copper, and I'm going to have some sulfur left over. All right? And so like I said, it's really just like a 2-for-1 problem. So let's look at another example. And yes, I know these are long, but you know, again, the more you practice, the faster you get, and it's not that bad. And so here I just got slightly different numbers because I was rounding my molar masses differently. All right, so if you feel comfortable, try the top one. If you don't, then you can watch me do the top one, and then you can try the bottom one. All right, so it says if 75.6 grams of C2H4 is reacted with 201.6 grams of oxygen, how many grams of carbon dioxide is produced? Okay, so again, we are going to go from here to our product, and then from here to our product, and then we'll pick the lower amount. All right, so I'm going to start with the 75.6 grams of C2H4. So first step is convert to moles. I'm going to start speeding up a little bit on the 3 steps because I'm going to kind of assume you've gotten that down, mainly because we need to finish the video in less than 5 hours. All right, so I'm going to convert to moles using molar mass. So when I add up C2H4 on the periodic table, I get about 28 grams per mole. Following the golden rule means 28 grams goes on bottom and 1 mole goes on top. So next step is mole ratio using coefficients. I can see that 1 mole of C2H4 makes 2 moles of carbon dioxide. I'll put the 1 mole of C2H4 on bottom so I can follow the golden rule, and the 2 moles of carbon dioxide on top. So you can see that now I have officially switched over to carbon dioxide. Step 3 is to convert to unit asked for. Well, it asked me for grams of carbon dioxide, so I'm going to use molar mass. So I add up carbon dioxide off the periodic table, I get 44 grams per mole. So since mole is on top, I'm going to put the 1 mole on bottom and the 44 grams on top. So once I multiply across the top and divide by the bottom, I get 237.6 grams of carbon dioxide. Now remember, I don't know if that's how much I'm actually going to produce yet. I have to wait and do my oxygen to see. All right, so let's move on to our oxygen. So I'm starting with 201.6 grams of oxygen. So step 1 is, of course, convert to moles. Since I have grams, I'm going to use molar mass. O2 is 32 grams per mole, and since grams is on top, I'm going to put the 32 grams on bottom and the 1 mole on top. So my grams cancel. So now I'm at step 2, which is mole ratio. So I can see that 3 moles of oxygen makes 2 moles of carbon dioxide. Because moles of oxygen is on top, I'm going to put the 3 moles of oxygen on bottom and the 2 moles of carbon dioxide on top. So my oxygen cancels. And then last step is to convert to unit asked for. Well, again, I asked for grams of CO2, but remember, I just did that step right here. So I can just pull that step down. 1 mole of carbon dioxide is 44 grams. So I multiply across the top and divide across the bottom, and I get 184.8 grams of CO2. So now that I can see my 2 amounts, I can see that this is how much I will be able to produce, because once this amount is made, I'll be out of oxygen. So if it asks me to identify the limiting and the excess, I can say, okay, well, here's the lowest amount. Oxygen made the lowest amount, so my limiting is O2. And then here's the greater amount, and C2H4 is going to be in excess. Now, one thing I want to point out is notice that the one we had more of actually ended up being the limiting. A lot of times y'all want to think that, oh, well, if there's more, that's obviously going to be excess. You can't compare grams to grams like that in a reaction because every substance has its own molar mass. All right, so if you haven't paused and tried one yet, make sure you pause and try this one. I'm going to erase this top part and work this one out up here just so that y'all can see it better. But pause it and try that one and see if you can get that one right. All right, so it says when 6 grams of HCl reacts with 5 grams of magnesium, how many grams of magnesium chloride is produced? So I'm going to go from here to here, here to here, and then I'm going to pick the lowest. All right, so like I said, I'm going to put my answer up here though. So please know I'm working out this question. So I'm going to start my 5 grams of magnesium first. So 5 grams of magnesium. Step 1 is convert to moles. Since I have grams, I'm going to use molar mass. So for magnesium, it's about 24 grams per mole. So to follow golden rule, I'm going to put 24 grams on bottom and 1 mole on top. ratio using the coefficients. So I can see that 1 mole of magnesium makes 1 mole of magnesium chloride. But to follow the golden rule, I'm going to put the 1 mole of magnesium on bottom and the 1 mole of magnesium chloride on top. Remember, the golden rule is not just about canceling units, it's about canceling the unit and the substance. Alright, so step 3 says convert to unit ask for. Well, they asked me for grams, so again, I'm going to use molar mass, but this time I'm going to add it up for MgCl2. And when you do that, you should get about 94 grams per mole. So since mole is on top, I'm going to put my 1 mole on bottom and my 94 grams on top. So then I multiply across the top, divide by the bottom, and I get about 7.8 grams of magnesium chloride. But again, I don't know if that's my answer yet or not because I still have to see what's going to happen with the HCl. So let's do that step. So hopefully you got that part right so far. So let's start with our 6 grams of HCl. So 6 grams of HCl is what I'm starting with. And step 1 says convert to moles. Since I have grams, I'm going to use molar mass. So when you add up HCl off the periodic table, you get about 36 grams per mole. So I'm going to put my 36 grams on bottom so I can follow my golden rule, and my 1 mole on top. So see how stoichiometry is all pattern. That's why I say it's so logical. It's just a pattern. Alright, step 2, we're doing mole ratio. So in this case, 2 moles of HCl makes 1 mole of my product. Well, since I have HCl on top, I'm going to put the 2 moles of HCl on bottom and the 1 mole of my product on top. So my moles cancel. So see, now I switched over to MgCl2. So last step is to convert to unit asked for. Well, in this case, it asks for grams, and so remember, y'all, we just did the molar mass of MgCl2, so I'm just going to pull that step down. So 1 mole on bottom, so that it will cancel, is 94 grams on top, which we just got that from adding up MgCl2 off the periodic table. So once I multiply the top and divide by the bottom, I got 19.58 grams of MgCl2. So how much am I going to create in reality? Well, I'm going to pick the lower of the two. So it's 7.8 grams. And then, like I said, if it asks you for limiting and excess, limiting made the lower amount. So limiting would be magnesium. And excess makes the larger amount. So the excess would be HCl. So hopefully you got that one right. Okay, so let's look at what one of these looks like when we don't have to do all 3 steps. Because like I told you in the previous video, you don't necessarily always need to do all 3 steps. I'm just trying to get you really good at doing all 3 of them. So then when you don't have to, it's super easy. So let's look at an example like that real quick, and then we'll be done with this video because it's getting kind of long. Alright, so it says how many moles of NH3 can be formed from 3 moles of N2 and 6 moles of H2. Okay, so again, we know it's a limiting reagents problem because I have 2 starting amounts and I'm trying to figure out how much product. That's how you know it's going to be a limiting reagent, even if they don't say it in the question. Alright, so that means I'm going to go from here to here, get an answer, go from here to here, get an answer, and then I'm going to pick the lowest. Alright, so I'm going to start with my N2 first. So I have 3 moles of N2. So, step 1 is to convert to moles. Well, I already have moles, so I don't need to do step 1. Okay, and see, that's what some of y'all, you get in the habit of just always doing step 1. So it's like you force it, and you'll try to do molar mass. Well, I already have moles, so I just skip it. So, second step is mole ratio, the coefficients. Well, because I am going from one substance to another, I always have to do mole ratio. So I can see that 1 mole of N2 makes 2 moles of NH3, so I follow my golden rule and put the N2 on bottom. So 1 mole of N2 from this coefficient makes 2 moles of NH3. So see, I officially switched over to NH3. Step 3 says convert to unit asked for. Well, if you look, I asked for moles of NH3. Well, right now, I already have moles of NH3, so I don't need to do a step 3. I would only need to do step 3 if I asked you for grams, liters, or molecules. Okay, so I'm done. I just put equals, like I got to skip step 3. So clearly, we just do 3 times 2, which is obviously 6. But, of course, I don't know if this is right yet because I need to see what happens with hydrogen. Okay, so like I said, this is what it looks like when you get to skip steps. Because the problem is some of y'all, you get so into the 3 step that then when I takes them away, you have trouble. All right, so now I'm going to start with my 6 moles of hydrogen. Step 1 says convert to moles, but I already have moles, so I can skip step 1. Step 2 says mole ratio. Remember, if you are switching to a different substance, you can never skip mole ratio. Okay, so I'm starting with hydrogen. So 3 moles of hydrogen makes 2 moles of NH3. So since hydrogen's on top, I'm going to put my 3 moles of hydrogen on bottom, my 2 moles of NH3 on top. So my moles canceled. So now I made it to NH3. Step 3 is convert to unit asked for. Well, I asked for moles of NH3. Well, I'm already there, moles of NH3, so I can stop and calculate my answer. So I multiply the top, divide by the bottom, and so in this case I get 4 moles of NH3. So in reality, I would make 4 moles because that's my lower amount. Then if they ask me for limiting, hydrogen made the lower amount, so that would be my limiting. And if they ask me for excess, nitrogen made the larger amount, so that would be nitrogen. Okay, so like I said, you're not always going to have to use all 3 steps, but sometimes it's a struggle for some of you when I finally take some of the steps away. So just be careful. Make sure you stop and ask yourself, do I need to convert to moles? Or do I need to convert to the unit asked for, or do I already have those? All right, but otherwise, this is limiting reagent. If you watch part 2, we just go into more limiting reagent problems and a few extra types of questions.